now talk about the components that can be found in an electric circuit, which is the resistor. We have earlier said that all conductor or material provide a certain opposition of current. All conductor or materials have their own opposition of current. But if you are not satisfied with the amount of opposition of current the conductor is provided, you still need to provide more resistance. There is a component specially designed to do that. A component specially designed to provide an amount of resistance is what we call a resistor. A resistor is a component which is specially designed to provide a known amount of resistance in a circuit. So there is difference between resistance and resistor. A resistor is a component that can provide a certain amount of resistance, but a resistor is just the opposition of flow of current. You can find resistance in the conductor itself. You can find resistance inside a cell. And a resistor can also provide resistance. So don't get it confused. There is a difference between resistance and resistor. Now, there are different types of resistors. We can classify resistors in two. Now, a resistor that can give you a fixed amount of resistance is what we call standard resistor. While a resistor that can give you varying values of resistance is what we call variable resistor. So if a resistor just give you only 2 ohms, the resistor is providing only a resistance of 2 ohms. That type of resistor is what we call standard resistor. Nothing less, nothing more. 2 ohms. Or, for example, 10 ohms. Nothing less, nothing more. That is standard resistor. And this is the diagram that is used to represent a resistor in a circuit drawing. Why a variable resistor? You can have a resistor, maybe the value can vary from 2 ohms to 4 ohms. 2 ohms to 4 ohms. You can adjust it. That is an example of a variable resistor. And this is the diagram. The only difference between the two, you are seeing the arrow. So when you see an arrow with this diagram, it becomes a variable resistor. A special kind of variable resistor is what we call your rheostat. A special type of variable resistor is the rheostat. Now that you know what a resistor is, for some reasons or whatever reason, you can choose to have more than one resistor in an electric circuit. So how do you combine them? You see between your parallel and series connection. So you can combine 2 or more resistors in parallel or in series for whatever reason you may wish. Now take note, we have said this before. When you connect components in series, for example, as I was saying, when resistors are connected in series, take note, the currents through each resistor are same. When you have whether 10 resistors and they are connected in series, the current that is flowing through them, they are always the same. While the potential difference across these resistors in series are different. Once again, the currents when resistors are connected in series, the currents through each resistors are same. While the potential difference across the resistors are different. Now, when resistors are arranged in parallel, the currents flowing through these resistors are no longer the same, but they are of the same potential difference across each resistor. When resistors are arranged in parallel, the current through each resistor is different, while the potential difference across the resistor is the same. Please, this is very important, and we are going to make use of it as we proceed. Now, note, a load in a circuit also has its own resistance. We have said you can find resistance in a cell. A resistor is that component that cannot provide a certain amount of resistance. And always that they know there is still a form of resistance. And we have just said that you can connect your resistors in either series connection and parallel. Now, if you now add them in series and in parallel connection, we will be interested in knowing the equivalent resistance of these resistors connected in series or in parallel. And that is what we want to do. I've earlier given the formula for it. In this example, we say 3 resistors of resistance 1 ohm, 2 ohms, and 4 ohms are connected in series. So you have 3 resistors with their resistance giving us 1 ohm, 2 ohms, and 4 ohms respectively, and they are connected in what connection? In series. Now we are now asked to find the equivalent resistance of the combination, the equivalent resistance, that is the total resistance that you can get from this three resistor. As we know, the formula will not be something of this nature: R1 plus R2 plus R3, because we are dealing with three resistor, and it's in parallel, in series connection, in series. Now our resistance of the first resistor is 1 ohms plus 2 ohms plus 4 ohms, which will give us 7 ohms. So the equivalent resistance is 7 ohms, as simple as that. So you just add it straightforward. The equivalent resistance of the three resistor is 7 ohms. Now let's take another example. For this example, the connection of the resistors are in parallel. We still have three resistors, but they are in parallel. And we are asked to find the equivalent resistance. As we know, when you are calculating for equivalent resistance or total resistance of resistors connected in parallel, the formula is 1 over R1 plus 1 over R2 plus 1 over 3. Based on the idea that we only have three resistors in this question. And the first resistor is 2, so it's 1 over 2 plus 1 over what? 3 plus 1 over 5. Then the next thing is to find the LCM of 2, 3, and 5. The LCM of 2, 3, and 5 is 30. Now 2 divided 30 will give us 15. 15 times 1 is 15. Plus 3 divided 30 is 10 times 1, which is 10, plus 5 divided 30 will give us 6. 6 times 1 is 6. So this will lead us to 1 over ROT is equals to 15 plus 20 will give us 25. 25 plus 6 will give us 31 over 30. We are not looking for 1 over ROT, we are looking for the equivalence resistance. So change reciprocal on both sides becomes ROT over 1 and 30 over 31. So this will give us our equivalence resistance. If you take note, if you pay attention, like in this work it out for you to try your knowledge of what we have done. We have 4 resistors of this resistance: 3 ohms, 5 ohms, 7 ohms, and now this one is connected in series. While the other question is still the same thing, only this time around the 4 resistors are connected in parallel. Now when you do the calculation, right, to series, the equivalent resistance will be this. And if you do the calculation right, the equivalent resistance for parallel connection should be this. Now, like I said, if you pay attention, especially for this one that have the same resistance of the same resistor, you will notice that the equivalent resistance is bigger in series and smaller in parallel. So when you are designing your circuit, these are some of the things you pay attention. Series connection gives a bigger equivalence resistance, while parallel connection gives a smaller equivalent resistance. Now,
we are done with what a resistor is. We now know that if you connect resistor in series and parallel, how well to give the equivalent combination of the resistance. And note, when you have some resistor connected in series, we say the same current flows through all this resistor, but you have different potential difference across this resistor. If you have 2 or more resistors connected side by side, which is a parallel connection, they are at the same potential difference, but different currents flow through them. Without wasting much time, we want to talk about a law that is very interesting and very vital when it comes to current, electricity, flow of charges. And that law is called Ohm's law. Ohm's law. Ohm's law is a law that talks about the relationship between law states? Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference across its ends, provided temperature and other physical conditions are kept constant. Ohm's law. Ohm's law. So there's a relationship between current, direct proportion between current flowing through the metallic conductor and potential difference across its edge. Now the formula for Ohm's law is V is equals to I R, where R stands for resistance of the material. So the law that captures, the formula that captures Ohm's law is V is equals to I R. And if you take notes, the bad law, it says there is a direct proportion between what? Current and what? Voltage. That is to say, if you increase the potential difference, the rate at which charge will flow or the current will also increase. So if you decrease the potential difference across the end of the circuit, the current will also decrease. The higher the potential difference, the higher the current. The lower the potential difference, the lower the current. Provided some conditions are kept constant, like resistance of the wire. Because resistance of the wire can also change. There is, for every material you have a fixed resistance of that conductor, but it can also change. But if you keep it constant, those two have a direct proportion. Those two have a direct proportion. But take note, Ohm's law is not obeyed by all materials. Ohm's law are not obeyed by all conductors. Such conductors that do not obey Ohm's law, we call them non-ohmic material. The examples are radio bars, transistors, rectifiers, and gases. Not all conductors obey Ohm's law. Examples are transistors, rectifiers, gases, and radio values. These do not obey Ohm's law. These do not obey Ohm's law. These do not obey Ohm's law. What we want to now talk about is internal resistance.